Hey everybody, and welcome back to Front-End Expert. In this video, we will be discussing objects. Objects are the most basic data structure we have other than the primitive types, and their purpose is to store key value pairs. So we can create an object by just saving it in a constant or a variable. So for example, I will say const website and set this equal to, and we will use the object literal syntax, which is simply curly braces, and we can add a semicolon at the end. And then we define key value pairs. So the keys in an object for the most part will be strings. However, you don't actually need the quotation marks. For example, I could say name, and then we can give this a value, and this value can be just about anything in JavaScript. For example, I will set the name to be equal to a string, and this will be algo expert. And then we simply separate the different key value pairs using commas. After the name, maybe algo expert has a rating of 5, so we can use a number as a value as well. And maybe we have the founders, and this will be an array, so we can have other objects and arrays within the object. So we can have the founders, and this will be an array with Clement and Antoine. And then finally, we could also have a Boolean, so maybe is awesome, and we can set this equal to true. This is the basics of declaring an object. Now, you can also have object keys with spaces in them, but if you do want to do this, you can't just declare it without the quotation marks. So for example, I can't say multi-word key and then set it equal to something. So I couldn't do this. This isn't going to work because of the fact that we have these spaces. So what we'll need to do is add quotation marks around the multi-word key, and then this will actually work. And finally, we could also use a variable as a key, as long as that variable is a string. So for example, I could say const my key and set this equal to, let's say, key. And then I could come down here and add another key value pair, and we will put this in brackets, sort of like it was an array. And we could say my key, and then we can set this equal to whatever value we want. So 1, 2, 3, 4. And now I could come down here and console.log out our website, and you will see that we get the website that we have defined here. So we have the name of Algo Expert, the rating of 5, the founders of Clement and Antoine, the is awesome set to true. We have that multi-word key with the 0. And finally, we have that key that is 1, 2, 3, 4. And you'll notice that it says key here, which is the string value that we had saved in the myKey variable. Okay, but just for conciseness, I will remove the myKey, and we can remove these last few lines of the object as well, and we can print this out again, and now you can see we simply have the name of Algo Expert, the rating of 5, and the founders of Clement and Antoine. And if we want to traverse the object, so if we want to get, say, the name of the object, we can simply use dot notation. So I could say website.name, for example, and this will print out Algo Expert. We could also use bracket notation for this. So I could say website and then brackets, and we put the key as a string. So I could say website brackets and then name, and this will print out the same thing. So we get the name of Algo Expert. Now, most of the time you will see that we will use the dot notation, but the bracket notation is useful for a few things. One, if you have a multi-word key. So if we had the key that was like name something else, we couldn't use dot notation for this because we would just have spaces in the middle of it and it would confuse the language. So we need to use bracket notation for that, as well as if our key had something like a dash inside of it. So if we had like name dash something, then if we tried to use dot notation, it would try to treat this as subtraction, which we don't want. So again, we would need to use the bracket notation for that. And if you want to avoid ever having issues with it, you can just always use bracket notation. But most of the time you will see people using the dot notation unless they absolutely have to. The other benefit of the bracket notation, though, is you can use it for variables. So for example, I could say const key equals, and maybe we get name here. And then instead of this string, I could say key, and this will print out Algo Expert. But if I tried to use dot notation, we are actually going to get undefined. The reason being that we don't currently have a website.key. So this isn't treating this as a variable. It's trying to get the value of key. So it's not using this key constant at all. This is the same thing as if we just didn't have this line of code and we still get undefined, which is an interesting point about objects. And that's that any property that we don't have is just undefined. So it's not going to throw an error if you try to get a property that doesn't exist. It will simply log out undefined, which can be good and bad. It can sometimes lead to some bugs. It can lead to tricky to debug code, but at the same time, it makes it so that our websites aren't throwing errors too often, which is nice. Okay, so let's get rid of this code. And now let's look at how we can actually change the website. So we can change our object. So we could say website.name, and we can treat this just like a variable. So for example, I could change the name to be front-end expert. And now if we console.log website.name, you'll see the object has changed to have front-end expert instead of algo expert. And something that's worth noting here is that even though we declared the website with a constant, we can still change properties on the website. The reason being that we are not changing the declaration of this website. It is still pointing to the same object. We are just changing the values within that object. And we can also add properties that weren't there to begin with. For example, I could say website.foo and set this equal to bar. Then when we console.log out the website, you'll see that now it will contain the property of foo set to the value of bar. And then finally, if we want to remove a key value pair, what we can use is the delete keyword. So I could say delete website.foo, and then we can once again console.log out the website. I will remove this other console log. So we have added foo, but then we immediately delete it. And now you will see that there is no more foo because of the fact that we deleted it. So we used this delete keyword to remove something from the object. Okay, so a few more key points about objects. Let's remove this code. And what I want to do is console log. We're going to set two objects equal to each other. And what we're actually going to log here is going to be false. The idea that I want to show is that two objects are not equal to each other based on their values. So when we compare objects, we are comparing, are these the same object? And the same is true if we use double equals, we still end up getting false. However, if I say const obj and set this equal to an object, now if we set one of these variables equal to obj, it's still going to be false because we are comparing this object to this object. However, if we remove the second object and set obj equal to obj, it will be true even if we use strict equality because of the fact that these are the same object. Okay, next, what we can look at is a shorthand notation that can be nice for declaring objects based on variables we already have. So for example, let's say we had const name and this was Connor. Then inside of our object, we might want to do something that was like name and set this equal to our name variable. And then what we can do is console log out the object, and you will see we get name as Connor. And what we can do instead is we can just say name. And this is a shorthand notation for the same thing. So what this does is it takes the name as the key. Then it also looks for the value that is stored in the name variable and sets that equal to the value. So this is identical to what we had before. It is just a shorter notation, and this can be super convenient when you're declaring an object with a bunch of values that already existed in variables or constants. Okay, so next what I want to look at is we have another way that we can actually create an object. Using the object literal syntax is how we usually do it, but there is one more way we can do this, and what we can do is we can say const and give this some name, so I'll call this obj, and we can set this equal to a new object. So there's an object constructor that we can call, and then if I did console.log of obj, you would see that we have an empty object. And then, of course, we could come before the console log statement, and we could add something to this object. So I could say obj.name, for example, like we've done before, and set this equal to Connor. And now when I log this out, we have name being the string Connor. So this is just another way to create an object. Most of the time you'll see object literal syntax, but it's good to know that this syntax works as well. Okay, so next what I want to look at is the idea of a constructor. What would happen if we wanted two objects with the same keys but different values? Well, we could just create the objects, but it would feel a little bit redundant. So what we can do instead is we can write these functions that are constructor functions. We can simply say function and then the name of the constructor we want. So for example, I will call this website, and you'll notice I used a capital W. This is just a naming convention. It's nothing special in the language. In fact, there's nothing special about these constructor functions at all. They are simply functions. But inside of this website, we can take in, let's say, a name, a rating, and founders. And then what we can do is we can open up this function, and we will use the this keyword to reference the object that we are creating. For example, we can say this.name and set this equal to the name that was passed in. We can say this.rating and set this equal to the rating that was passed in. And we can say this.founders and set it equal to the founders that were passed in. Then next, what we need to do is actually use this website constructor. So what we can do is we can say const, and I'll call this one frontend expert, and we can set this equal to a new website. The way this works is whenever we use the new keyword, it creates a new object for us. And the object is set equal to this. So this call inside of website will then become the new object. That's why we can set properties using this.name, this.rating, and this.founders. And then when we return here, it's going to return that object to us. So it's going to save it in frontend expert. Now inside of website, we can say frontend expert. We can give it a rating of 5, and we can give it founders. For now, I will just put myself. And then what we can do is we can console.log frontend expert. And what this has done is it has created a website with the name frontend expert, the rating of 5, and the founders of Connor. Okay, so now let's remove the function constructor. And what I want to look at next is something called a symbol. So we can create a symbol with, let's say, const, and we'll call this one ID, and set it equal to a symbol, and then we pass in a description. So we'll just call this ID. And what a symbol is a unique identifier. The call to symbol ID will return a symbol to us, which is a primitive type, but two calls to symbol ID will return different unique identifiers. And we can use these as keys inside of an object. So for example, I could say const obj, and we can set this equal to an object, and we can use the ID, so the symbol, and set it equal to, let's just say 1, 2, 3, 4. And now let's console.log out the object, and you'll see our key is simply the symbol ID. But what's interesting here is if I was to copy and paste this, and we had ID2, and these symbols have the same description, they are actually different. So if we did console.log ID equals ID2, we are going to get false. We even would get false if we did the loose equality operator, because these are completely different primitive values. So symbols can have a variety of different use cases, but one of their most useful properties is that they are hidden from most iteration functions. And we will see this in a moment when we look at iterating through these objects. But as an example, we might want to use a symbol when we need to add a value to an object that we got back from a third-party API. But we want to make sure that our new property doesn't interfere with any of that third-party API's code. This will make sure that our property doesn't appear in any iteration functions, and that it doesn't accidentally override any properties that were already on the object with the same name, since symbols are by definition unique names. For example, if we were using this as an ID, but then for some reason this object also had some other key that was called ID, then we would actually get to have both of these on the object. So I'll just set this equal to the string hello. And now if we run this, you can see we have the string hello and the symbol ID. So we can have both of these at once. We could also even have the ID2 on here, so we could have multiple symbols. And I'll set this one equal to just say 0. And now you'll see we have both of these symbols. It's a little bit confusing because they both say ID in the console. That is because they both have the ID description. But for example, I could call this ID2. And now we would see we have ID2 and we have the standard ID. But this does bring up another point that you can't have duplicate keys in an object. So if I had another ID here and set this one equal to world, now what we get is the ID is simply world because of the fact that this ID has overridden this one. So if you have two of the same key, it's just going to use the last one that was added to the object. Now, sometimes you do actually want the symbol to be the same. So maybe you want to have the same symbol exist on multiple different objects. And what we can do for that is, let's say we'll call this one ID3. We can set this equal to symbol.for. And what this does is it does just that. It creates a symbol, but whenever we use the same name or description here, we are going to get the same exact symbol. So for example, if I did this again, so we did call this one ID4, but we used the same value inside of symbol.for, and we said console.log ID3 is the same as ID4, we are going to get true because we had the same symbol. So this printed out true. The false in the console is coming from here. I'll remove that to make it a little bit easier to see. So we get true here because of the fact that we had the same value in symbol.for. And this comes from something called the global symbol registry. So essentially it is just a global holder for symbols, and it looks to see if there's a symbol that already had this value of ID3. And if it is, in the registry, it's just going to return you the same symbol versus using the standard symbol function is going to return you a different symbol every single time, regardless of if you give it the same value or not. Okay, so now let's remove this code once again. And what I want to look at next is how we can see if an object contains a key. We can come down here and say console.log. And what if we wanted to say, does this object have a name key? Well, there's a few ways we can do this. First, we could do a string name, and then we can use the in operator, and we can say in website. So is there a key with the string name inside of website? And you can see this will log out true because there in fact is a key with the string name. But then as an alternative to this, what we can also do is we could say console.log, and we can say website.hasOwnProperty, and then we can pass in the key. So I could say name here, and this is also going to print out true. So what's the difference here? What's the difference between the in keyword and the hasOwnProperty function? Well, it's actually in the name. hasOwnProperty is checking what we call own properties, which are properties that are defined on this actual object, such as name. On the other hand, the in keyword looks at properties on this object, but it also looks at properties on objects that this object inherits from. And we will see more about inheritance in a bit and later on in the crash course. But the big issue here is just that website is actually inheriting from the root object. For example, that object has a toString function. So if we print out toString as in website, this is true. But if we do website.hasOwnProperty of toString, we get false. And the reason for this is because of the fact that toString is not defined on this website object. It is only defined on the object that it is inheriting from. So the in keyword includes those inherited, what we call prototype properties, versus the hasOwnProperty only includes the own properties, which are the properties we have actually defined on the object. Now, there is a third way to do this. Sometimes you will see, let's say console.log, and we could say website.name does not equal undefined. And the idea here is that if we did website.name and it wasn't a property, we would get undefined. And this does work. It returns true because website.name is not undefined. And if we were to remove website.name, it would return false. But the issue here is if we set the name explicitly to undefined, now hasOwnProperty of name is going to be true because we do have a property called name. but website.name does not equal undefined is false. The reason that this is false is because name was actually set to undefined. So I usually don't recommend doing this. I would almost always recommend using the hasOwnProperty function and occasionally using the in keyword if you need to include the inherited properties, but most of the time we will use hasOwnProperty. Okay, so let's put this back to algo expert and we can remove these console log statements. Next, let's take a look at what we can do to start adding methods to these objects that we are creating. So we can come down here and the first thing we could do is maybe let's call this say hello, and we could set this equal to a function. So for example, I could use an arrow function here and we could do console.log hello. And then what we could do is we can say website.sayHello, and you'll see that we end up logging out hello. However, there is a syntax for methods on an object that we can use instead. So instead of the syntax here, we can get rid of the colon, and we won't use an arrow function for this. We will use curly braces to open up the method, and then we can simply put the body of the method inside, and this will work the same way. Now we have the say hello method on the website using the more traditional method syntax for the object rather than having an arrow function set equal to a standard property. Now we can also use what we call getter and setter methods. So I could use the get keyword and let's say get rating. And what this is going to do is it's going to define a method that gets the rating from the website. So for example, we can just say return this.rating. So we will use the this keyword to reference the object we are in. And the weird thing about how this is going to work is we can say console.log and we can do website.getRating, but we won't call this as a function. We will use it like a standard property, and you'll see that this will log out 5. And then we can also use a setter function. So we can say set, and we could do set rating, and this is going to take in the value. And rather than returning the rating, what this one's going to do is say this.rating equals the value that we passed in. And this is going to work, again, just like a standard property. So I could say website.setRating and set this equal to, let's say, 6. Now, if I do console.log website.rating, you'll see we log out 6. We could also do this by calling the website.getRating function instead. So I could do website.getRating, and we need to console log this out as well. So we can wrap this in a console log statement. So console.log website.getRating, and you'll see this also logs out 6. So the get function is usually going to be the same thing as simply getting the value, but we could do something else here. So we could do getRating could return this.rating times 2, for example, and now you end up getting 10 and 12 because we are multiplying by 2. So this is a standard method. We can do any other code we want in here. We don't have to just return this.rating. Okay, so now let's remove the methods from this object. We aren't going to need those anymore. And what I want to look at next is how we can make an object inherit from another object. So let's create another object. We can call this const obj, and I will make this object inherit from the website object. So this will be another website. And the way this works is we use 2 underscores and then proto, and then 2 more underscores, and then we set this equal to the object we want to inherit from. So for example, I could say website. And now if we were to console log out obj, it would just print out an empty object since this object has no own properties. Although in the Chrome console, it will let you open up the prototype. But regardless, we do have access to those inherited properties. So for example, I could console log object.name, and this will log out algo expert. And the reason this works is because it looks on the inherited object if it doesn't see it on the actual object. We will go much more in depth on this throughout the crash course, but I just wanted to briefly show how this works. We could also add other properties here. So I could say foo, set this equal to bar, and we are still able to log out object.name. And if we logged out the whole object, we get foo set equal to bar, but we don't see any of the values on the website proto chain unless we go into that inherited property. And again, we will see much more of this throughout the crash course. I just wanted to briefly introduce it in this portion of the video. Okay, so now what I want to do is come into this object and let's also add a symbol. So I'm going to call this symbol, and we can call the symbol ID. And for now, we can just set this equal to 0. And now what I want to look at is how we can iterate over an object. And the reason I created this second object is that when we iterate, there are different ways that properties can be treated based on if they are an own property, if they are a symbol, and if they are a property coming from the proto, so the prototype chain, which is the inherited objects. Okay, so there are 3 main functions that we will use for iterating over an object. So we can call object.keys, and this takes in the object. So for example, obj. And let's console.log this value. So we can say console.log object.keys. And what this does is it returns an array with the keys. But this doesn't include every key. First, it is going to exclude any keys that are not own keys. So any inherited properties are excluded. Next, it excludes what we call non-enumerable keys, which are literally just properties excluded from this iteration. By default, all of the keys we add with string names are enumerable, so we don't really need to worry about this. This also excludes the symbol, so we are not going to see symbols with this basic version of how we are iterating over the object, and we don't see any of the keys in the proto chain. And there are 2 more functions we can use that are just like this. So we'll copy this code, and we can also do .values, and this is going to return an array of the values. So keys got foo, whereas values got bar. And then we can also do entries to get both at once. So we can do entries, and what this does is it gets us a nested array of each key value pair. So if we had one more key value pair in here, so we could give this a hello and set it equal to the string world. Now you'll see we get foo and hello for the object.keys. We get bar and world for the values. And for entries, we get all of it. So we get first an array with foo set to bar, and then we get an array with hello and world. But again, all of these are ignoring the prototype as well as they are ignoring the symbol. Okay, so now if we want to actually iterate over these values, we can just treat the return values of these functions as arrays because they are arrays. So for example, we can do object.entries of the object, and because this returns an array, we can call .forEach. And then inside of forEach, we simply pass in a function. So for example, a function, and for now, let's just do value. Then inside of this function, let's console.log out the value. And now you'll see we iterate through and we console log out foo bar as an array, and then we console.log out hello and then world as an array. And we can also use destructuring syntax here. We will see this in the video on syntactic sugar. So for example, we could pass in the destructured array here with key and then value, and then we could do something like key, comma, value, and you'll see now we print out foo and bar and then hello and world rather than having them as arrays. Okay, so now there is one more way that we can iterate through an object, and that's going to be for, and then we can say key in, and then the object. And what this does is it assigns each key to the key value within each iteration of the loop. So for example, we could do console.log key. And just like the other versions of iterating that we've seen, this is going to see some properties and not others. So what this is going to do is it's going to always see the own properties like foo and hello, but it will ignore the symbol properties. However, the difference between this and using object.entries or object.keys is that it is going to actually see the so the website that it is inheriting from. So in the prototype chain, it will actually be included when we do for key and object. But the one caveat here is it's not going to include what we call non-enumerable properties. And these are the default properties for the most part that are given to us by the browser, such as the toString function is not going to show up when we do this. So now If I run this code, you see we get foo, we get hello, and we get name, rating, and founders, which came from the website in the proto. So this is what we are inheriting from. The key difference is that for key in object is going to include inherited properties, whereas the object.keys or object.entries is not going to include those inherited properties. Okay, so next, let's move on from iteration, and what I want to look at is how we can copy an object. Let's say const, we'll call this myObj, and what we can do is we can set this equal to an object. And let's give this object one property, so we can call this original. So this original property was here from the beginning. I'll set this equal to 1, 2, 3. And then what we can do is we can call this object.assign function. And what this function does is it takes in a target object, for example, myObj, and then it takes in a source, for example, the obj object. And what it's going to do is it's going to copy all of the properties from the object over to myObj. But specifically, it's only going to copy the enumerable own properties. So let's see what this looks like. Let's console.log out myObj now, and you'll see we end up getting original with 1, 2, 3, which we already had. We copied foo and hello because these are own properties, and we copied over the symbol with the value of 0, but we did not copy over the proto website, so nothing that we inherited, and we did not copy over the non-enumerables. We aren't seeing the toString, things like that being copied over. They are already on this object anyways, but if we had created some non-enumerable, it would not be copied over. Okay, so next, there are a few other properties and functions to look at. First, let's look at object.freeze. And what object.freeze does is it freezes an object. So I'll pass in the website, for example. And what this is going to do is it's going to say that we can no longer change this object. It essentially makes it immutable. For example, if I was to say website.name and try to change this now to frontend expert, you'll see this isn't going to work. So we can do console.log out the website, and we will end up not having the name changed. So it is still algo expert. And it is worth noting that this behavior can differ a bit based on the context, such as if we are using strict mode. So sometimes this will end up throwing an error, and others it will just not do anything like we saw here. But regardless, object.freeze is not going to let you change the object. And we also can't add new properties, so if I tried website.foo and set it equal to bar, this is not going to work either. And finally, we can also do object.isFrozen to check if the object is frozen. So I could say isFrozen of website, and this is going to be true because we have called object.freeze, and I will console log this out to show that. So we can do console.log object.isFrozen of the website, and this logs out true because of the fact that we called object.freeze. But before that call, this would have returned false because we wouldn't have frozen the object just yet. Okay, now we also have this property seal, and seal works very similar to freezing an object, but the difference is that with seal, you can still change properties. So this is still going to work. I can still change the name to frontend expert, but I won't be able to create any new properties. So website.foo equals bar will not work. And similar to object.frozen, we have this function object.isSealed, and this will return true because we have sealed the object. And now you can see that we log out true because it is sealed. And when we print out the website, we have changed the name to be frontend expert, but website.foo equals bar did not have any effect. Okay, so now let's get rid of this code to make a little bit more room, and let's look at some last functions. For one, we can call website.toString. We've seen that this function exists, and all this does is it tries to return a string version of the object. But this isn't really going to do anything very useful right now, so we could do console.log website.toString, and all we get is this text object. That's not super useful, but that is what the toString function is going to do by default. However, if we wanted to, we could change this. So I could say website.toString, and I could set this equal to some function. And maybe this function, I want to return hello world. And now if we copy this website.toString call, as you would expect, we end up logging out hello world instead of simply the object string that we had before. And this can be useful because anytime that there's an internal function that needs to convert the object to a string, it is going to call the toString function. So if you need your object to be treated in a certain way as a string, you can do that by changing the toString function. And similarly, we have another function that is going to be value of. So we can console.log website.value of. And by default, this is just going to print out the actual website. So it's going to print out the object. So the value of the object by default is just that. It is the object. And the purpose of object.valueof is for when you need the object to be converted to a primitive, it will try to use this function. So we usually don't actually need to override this, but it can be something that's cool to do, and it can be useful in certain scenarios. So for example, we could do website.valueof, and we can set this equal to a function. And this function, what we want to do is maybe let's return 2. So now the value of this object is going to be 2. And now if I did something like console.log website -1, what's going to happen is the value is 2, so we end up logging out 1. And I will remove some of these other console logs just so that we can see everything a little bit easier. So you can see we log out the value of 1 because the value of the website is 2, and subtraction is using the value of method to convert our website into a number. In this case, it converted it into the number 2, and we subtracted 1, so we ended up with 1. And finally, there's one more function like this, and that is going to be toPrimitive. And this one we tend to not edit too often. It can be a little bit complicated to edit, but I'm going to add it directly on the object itself. And the way we do this is with a symbol. So it's going to be symbol.toPrimitive. And then this is going to be a function that takes in a hint. And the hint is going to be one of the string, either number, string, or default. So then inside of this function, usually what we do is some if checks. So we can say if the hint is, let's say, number, then we want to return how this is going to act as a number. So maybe we want to return 5. However, if the hint is equal to a string, so if we are converting to a string, then we need some string here. So let's return hello. And finally, we can add a default case. So if the hint is default, we can return something else. Let's return 2 in this default case. And default is going to be used in the case that it is ambiguous. The browser's not sure if you want a number or a string, and we can see that in a moment. Now let's come down here, and I'll make a little room so we can see what we're doing. And let's move these functions up just so we can see them all. And instead of console.log of website -1, first, what I want to do is simply try to convert our website. So let's see what the different conversions are going to do. So we can say console.log of, and first let's convert to a number. We can do number and then pass in our website. And this is going to end up logging out 5. The reason it logged out 5 is because symbol.toPrimitive, for the most part, is going to take precedence over the value of or the toString functions. So because we have this hint is equal to number, which is what was passed in, we return 5, and that is the value we get. However, if I had none of this symbol.toPrimitive and we run this code again, we get 2 because it defaults to the value of in the case that it cannot use toPrimitive. Okay, so let's put this back. And now instead of converting to a number, let's convert to a string. And you will see we get hello. The reason we get hello is because of the fact that we had hint as being a string, and we get hello. However, again, if we had no toPrimitive, then it will fall back to using the toString function. Okay, so now let's put these back, and let's do something that's going to act a little bit differently. First, let's try 10 minus the website. Then let's do console.log of 10 plus the website. And these are actually going to act differently. 10 minus the website returned 5, so it did 10 minus 5. And the reason for this is it saw 10 minus, so this is subtraction. So it said, okay, I need to convert this to a number. I have a toPrimitive function. We have a hint of number, return 5. Okay, 10 minus 5 is 5. But plus used 2. So that was using the default value here. So to actually show this, I will change value of to be 1, so we can show that this is using the 2, not the 1. It's using this value, not the one from value of. And the reason we do this is because plus is ambiguous. It could be either addition or concatenation. So we say 10 plus website, and this could either be 10 plus the number of website or 10 plus a string of website. And because we don't know, we go back to the default value, which is 2. So that default value is 2, so we say 10 plus 2, and we end up getting 12. And again, if we had none of this symbol.toPrimitive and we run this code again, we get 9 and 11. We do 10 minus the website, uses 10 minus the value of, and 10 plus the website, in the case we had no toPrimitive, is actually going to just use the value of, and value of is going to act sort of like the default. And because we returned the number 1 in value of, we get 11. But if, for example, I returned the string ABC, then we get not a number for 10 minus the website, and we get 10 ABC for 10 plus the website. So this ended up being treated as concatenation because the value of returned a string, whereas subtraction is just always subtraction. 10 minus the string ABC was not a number. Okay, so with that, that's going to be the end of this video on objects. There is more to learn about objects, specifically with relation to inheritance and classes, and we will see that in the video on classes. But for now, this will be the end of this video. I hope you enjoyed it. I hope you learned something new, and I'll see you in the next one.